So these are the main features in Civil 3D, which is the first one is road and highway design. In road and accelerate design, optimization, and documentation of road network and bridge project. We can work with an intelligent model-based approach for surface and corridor modeling, drainage layout, and plan production. And the second one is site design that can get your project off the ground quickly with tools to help you prepare and shape ground surfaces for roadway, subdivision, and other site projects. The third one is rail design. So in this rail design, we can design the speed, we can plan the speed, design, and delivery of transit station and rail network. So I will go through one by one. So for road and highway, we have a survey. Civil 3D allow user to use the Autodesk Civil 3D survey features to download, create, analyze, and adjust survey data. The survey features extend the functionality of Autodesk Civil 3D by streamlining the process of transferring field capture survey data and survey data to and from the office. Okay, so here in this video, you can see that I have the survey point that I get from the surveyor, and then with a few settings, I can bring the data. So I will fast forward this video. So here I do a little bit more on the setting one, and so here we have all the points from the data, and each point will indicate the elevation, and from the point we can create a surface 3D, and in the surface you can insert the contour in the background. Here I'm adjusting the surface. Okay, I will fast forward this video. Here is the surface that I get from the survey data. So if you didn't want to have the point, you can just turn it off. Okay, and then if you want to make a few adjustments, for example, if you want to delete some line or adding some line, you can go ahead and do so. Okay. So the next one is drainage design. Civil 3D provide tools for creating a pipe network with pipe network layout tools. Here it allows you to set the pipe layout properties such as a profile and section. You can also define your surface to lay out your pipe network. You can define the structure of pipe in the pipe part list. Then you can specify the station that you intend to lay out your pipes, as you can see on the screen. And then once you have your proposed pipe network design, okay, here my proposed pipe network design, I can view them in 3D. Okay, notice the 3D modeling that we have here is because all of the automation that is controlled by the pipe style. Okay, we can also create an alignment and profile from this pipe network. Okay, so with a pure setting, we now have all the data with the different and elevation. Your grading work can create a pond that will be needed for stormwater detention. The storm design has to do with collecting rainfall and conveying it to a safe location, and often treating it with some sort of pond or storage channel to slow down the flow of water. So line features, grading object and surfaces can be leveraged to shape the ground just what it needs to be for your site to slope, drain, and perform properly. Okay, then it can be used to design pipe network to collect and convey stormwater from your site. Okay, So basically CV3D will do all the hard work for you for all those inevitable design changes that are going to come along as the project progresses. Okay, next is we will take a look at how the parking tools within Autodesk vehicle tracking software can be used to conceptualize and test a parking in CV3D. So to access vehicle tracking features on the ribbon in CV3D, as you can see on the screen, you need to install vehicle tracking. If you purchase the AEC collection, Architecture, Engineering, Construction collection, you might notice that vehicle tracking is inside the AEC collection. So this vehicle tracking can help us in the parking lot layout and creating a parking stripes. So as you can see the video, I'm creating the parking stripes. Here you can define your standard of parking lot according to your project and simply click to specify the location of your parking lot. Okay, once you finish identifying your parking lot, vehicle tracking can dynamically change to make the parking lot align with the curves. And when you place parking row, Autodesk vehicle tracking will limit on how close you can put the parking row with another to maintain the minimum driveway according to the project standards. Okay, so this is the minimum driveway for the project standards. Okay, so we can leverage the parking row intelligent grid to modify the island not to approach the driving way. We can also run quick parking report indicating the number of parking and handicap parking. So Autodesk vehicle tracking will allow you to test your parking lot design. As you can see on the screen, I'm drawing a path for my vehicle out from the car park. And then a quick review of the analysis result can confirm the car can successfully perform its maneuver from the parking lot. Okay, next one is rail design. So this one is alignment and profile. So 3D polylines or feature lines from a rail alignment that represent the left, center, and right rail lines. Alignment is interactive with the profile, both existing ground and planned work. So the rail lines are created with common stationing based on a specified tolerance or interval. Once generated, rail lines will adjust to modification to parents rail alignment geometry, profile, and counts. Using profile, you can view changes in elevation along a horizontal alignment. Create a profile view to see one or more of the profile associated with a horizontal alignment. Okay, this one. You can use the profile view of a surface as a guide to create the finished grade profile of a design surface. So on a profile view, you can also superimpose the profile of a different horizontal alignment that is in the same area. So after the alignment is created, you can calculate how the corridor behaves around the curves. You can calculate super elevation along the center lines, offset and curve return alignment, or you can calculate cant along rail alignment. Okay, the next one is corridor modeling. A corridor model builds on uses of various Autodesk CV3D objects and data, including sub-assemblies, surface, feature lines, alignment, and profiles. So the corridor manages the data, tying various assembly to the baseline and their finished grade profile. Corridor objects include corridor body geometry, longitudinal feature lines, embedded surface, rendering support, and slope hatching support. So after you have created a corridor, you can extract data from it, including surfaces, feature lines, polyline alignment, profile, and grading features. And you can simulate driving through a 3D model using the drive command, as you can see on the screen. So when you start the command, you are prompted to select a path along with the drive mode views that will travel along the alignment. So the view changes. The view changes to drive mode view, and a conceptual drive type is can be displayed in the ribbon. Okay, in conclusion, with the current industry trend, we need to move out of our comfort zone in our traditional work process and embrace the new technology that are coming. With all the advantages and features that I have shown you just now throughout my presentation, I strongly believe that CV3D could be a great help into your next project.